At the beginning of the semester, we started with the airline problem. We said that the airline was charging a price of $240 and selling 100 seats. And then on another day, they lowered the price to $200 and they sold 180 seats. We used the data from these two observations and sketched the demand curve, and that demand curve passing through these 2 points gave us a demand equation. Q equals 580 minus 2P, or P equals 290 minus 1/2 Q. That original equation is represented by the red line that you see here. Notice that the data we had, those two quantities and prices, did not identify what the competitors' prices were or what the income levels were at that particular point in time. So if the income levels were high and the competitors' prices were high, then the quantities of 100 and 180 at these two prices could have been a consequence of what is called an income effect or a cross-elasticity effect. That if the competitor's price was high or rising, some of the customers would come over to our airline, and therefore our quantity demanded would increase because of their loss of passengers. If the income were lower and the competitor's price were lower, we would lose some customers to them, so our quantities would go down. So all we know at this original set of prices is the quantities that were sold, but we don't know if the quantities were high or low because of the competitor's price and income levels being high or low. We had 2 points, a two-dimensional analysis, and we should recognize that there are other factors that were important, and those would increase the quantities if those were higher and decrease the quantities if those were lower. Over time, we realized that pricing at 240 did not always yield 100 seats sold, but the average was rather 86.7. Similarly, pricing at $200 did not always yield 180 passengers, rather it yielded an average of 152 passengers. This suggests that the demand curve was shifting inward, and the question is what would cause that demand curve to shift inward. The levels of revenue at the lower quantities would obviously be lower, and the table in the center of the screen shows you what the revenues were rather than the original revenues at the larger quantities. The original revenue at a price of $240 was $24,000, and we saw that on average at a price of $240 the average revenue was only $20,818. Similarly, at a price of $200, the original revenue was $36,000, but over time we saw that revenue coming in at $30,400 on average, because as we pointed out, we were selling 152 seats on average, so 28 seats lower than the 180 originally sold when the price was set at $200. The data over time are plotted on the screen here in this chart, and we see that the data all range in price above $210 and below $270, and the quantities of seats sold were somewhere between 30 and 140. So that's what the original data looked like. Here are the original data that were used in the problem for the 16 quarters. We see the average number of seats sold and the average price that was charged in each quarter. This is in your textbook, chapter 4, table 4.1. Those data yielded the data points you see here, and when we ran the regression, we got the result that suggested that the demand curve was estimated to be Q equals 478.5 minus 1.63p. So we are concluding that the price is important to the demand equation, and that when we raise the price by $10, we would lose approximately 16 passengers. That would be the interpretation of the coefficient. What we do see from this estimated demand curve, which is different from the original estimate based on 2 observations, is that the demand curve has shifted inward over the 16 quarters compared to what the first 2 observations showed us. And we would interpret this traditionally as being a consequence of a lower level of income, the income effect, or a lower price by competitors. The firm would be interested to know what to do if it were to lower its price or raise its price to maximize profit. It's important that you know certain summary statistics, and the ones that I require you to know are the R squared and its associated adjustment, the adjusted R squared, the t-values, and pretty much that's it. The F statistic is kind of related to the t-value. However, because we recognize that this is not the full model, and because we see that there's an inward shift of the demand curve, we still don't have a good estimate for what happens when we increase or lower the price. The slope of the demand curve kind of gives us an idea, but if you want a more precise answer, because you know the demand curve has shifted inward, you want to find out what caused it to shift inward, and if you suspect that the inward shift was a consequence of a lower competitor's price on average or lower income over time, then you would want to get those data, competitor's price and income, and try to tease out what the true two-dimensional relationship would look like, i.e. what the true coefficient on the price variable would look like. We're seeing a 1.63 right now, but we are sensing that that's not the true coefficient. Let's go back to the textbook for the full data set that we are going to estimate, which is not only the quantity of seats sold and the price at which we sold those seats, but also the data on the competitor's price and the average income in the various market segments and over time. So the data for the competitor's price and the income have been collected. They're now added to the analysis, and we're going to re-estimate the model, the quantity of seats sold, column 1, as a function of the price that you're charging, the competitor's price, and the income. Estimating the model with the competitor's price and the income included gives us a new coefficient for the price, and we see the coefficient is going to be 2.1235, and the interpretation of that coefficient would be that a $10 increase in our price would lead to 21 fewer seats sold. Remember, the original estimate was 16 fewer seats, so we realize that once you control for a lower price and a lower income in the market in which we are selling, the true impact of raising the price by $10 would be 21 fewer seats to be sold. This truer model, this larger model with more explanatory variables, shows us then the danger of going with the first available model, because if you thought that you were going to lose 16 passengers and you were okay with that, the truth is that all else remaining equal, you will lose 21 passengers, and that is a more dangerous result, because if you were counting on those extra 5 seats to be sold, then you are going to lose more revenue, and this could push the airline into a loss situation if 16 seats left it barely making a profit. If we took the data from that regression equation, they're all summarized in the table at the top of the screen, and we rewrote at the mean values of competitors' price and income. Those mean values are 243 and 102.4, and that income variable or income series was an index. So if you plug in those mean values, you would get the data that you see in this table, the 251.5 and the 316.3. You add those numbers onto the 28.84, and the two-dimensional representation of the specification would be Q equals 596.6 minus 2.1235p. This is distilling down the multivariate demand function into a two-dimensional demand curve, and this is what it would look like. Remember, that is controlling for the income and the competitor's price, so when these change, the demand curve would shift around. So in the graphical analysis, D1 is the estimated demand curve when we have only 2 variables in the model, and when we have 4 variables in the model you see here, the slope on the demand curve would be flatter, as we see it here, the green demand curve D2. What that says is that if you lower your price, you'd actually make more money because the sales would be higher. For example, at a price of 200, instead of the model saying you will sell 152 seats, you would actually sell 172 seats. So that's another 20 passengers at $200, which is $4,000. So you can see that when we have the wrong model, you could end up making incorrect calculations. The extra $4,000, I'm sure, would go a long way towards the profitability of the airline. For instance, if that $4,000 would cause you to shut the airline down, we're losing $4,000 then 172 passengers would cause you to break even, for example, and say, well, we can stay in business. Whereas the decision based on D1 would suggest that the airline would lose, and the decision based on D2 would suggest that the airline was not going to make such a loss or would actually survive. This is why it's important then to have the true model, because if you're forecasting into the future, then you would want to use the best available model to come to the best conclusion.